Hi, hello everyone. Welcome to Vision classes. It's classes for IGCSE, GCSE student around the globe. So today we have to discuss one of the interesting topic of IGCSE physics. It's a thermal physics part. Fine. So you in thermal physics part you have a kinematic particle model of a matter, then thermal properties and temperature related laws are there. Then transfer of thermal energy. These are the topics are there, and I hope you must have gone through the theory part and even the examples. Examples are key to get AA star grade in IGCSE physics. For even extended student, you must have to look at more difficult questions. Fine. So here we have the paper for May-June 2022. There is a one question number 5. It says that specific heat capacity we have to define. All right. So how we define the specific heat capacity? It's the amount of heat required to raise 1 kg of material by 1 degree Celsius. It's a specific heat capacity, and this is 2-mark question, so you can explain it like this. I will repeat it. The amount of heat required to raise 1 kg of material by 1 degree Celsius. So here, for example, you can explain if you want to increase water temperature by 1 degree Celsius, you require certain amount of heat, right? So that's a specific heat capacity. Fine. All right. So the part is a bowl contains 500 centimeter cube of water at a temperature of 5 degrees Celsius. The bowl of water is placed in a freezer for several hours. Okay. When the bowl is removed from the freezer, it contains the ice at a temperature of negative 18 degrees Celsius. So density of water is 1000 kg per meter cube. So calculate the mass of water in the bowl placed in the freezer. So we have to calculate mass here, mass of water. So we have a given things are rho is equal to 1000 kg per meter cube. Okay, it's in meter cube. And volume, the bowl contain volume of water is V is equal to 500 centimeter cube. So 500 centimeter cube you have to convert into meter cube. So it will be 500 times 10 to the power negative 6 meter cube, means it's a 5 times 10 to the power negative 4 meter cube. So here we have a formula rho is equal to m over V. We have to calculate the m, so rearrange this formula. M is equal to rho times V. So rho is 1000 times 5 times 10 to the power negative 4. So it will be 0.5 kg is the mass that we will get. And this is 2-mark question. And if you write step by step answers like this, you will get out of out marks here. Are you getting this point? So I hope you are getting this one. Then nextly, you have a specific heat capacity of water is 4200 joule per kg degree Celsius. Specific heat capacity of ice is 2100 joule per degree Celsius, and specific latent heat of fusion of water is 3.3 times 10 to the power 5 joule per kg. So calculate the energy given out as water cools from the 5 degree Celsius to ice negative 18 degree Celsius. Fine. We have to understand the phases of water. Okay, so it's from 5 degrees Celsius to negative 18 degrees Celsius, right? So firstly we have here Q1 means we have the water conversion from the 5 degrees Celsius to 0 degree Celsius. Okay, here certain amount of energy is given out. All right, so then Q2 is water to ice conversion. So water to ice conversion is latent heat of fusion, isn't it? So then nextly Q3 process is 0 degree Celsius to negative 18 degree Celsius. All right, so these are the 3 processes that we water cools down. Fine. So we have formulas for each and every the energy given out. So we have m specific heat of water, specific heat capacity of water, C of water times delta T. All right, here we have a mass which is 0.5 kg times 4200 times 5 minus 0, which is equal to 10,500 joule. Alright, so this is first part. Then second part is water to ice. It's just a mass times latent heat of fusion, F, which is equal to 0.5 times 3.3 times 10 to the power 5 joule per kg. So it will be 165,000 joule. Okay, then the last one is the energy given out during the 0 to negative 18 degree Celsius. So that's a mc of ice times delta T, which is equal to 0.5 times 2100. So specific heat capacity of ice we have to use here, and times delta T is 0 minus 18. Okay, so it will be equal to 18,900 joule. Okay, so for the energy given out, total energy given out is equal to Q total is equal to Q1 plus Q2 plus Q3. So add three of them, use the calculator straight away, and you will get 194,400 joule. You will get the energy given out. So yeah, this is how means you have to solve or approach this question. This is for around 5 marks, and if you write all these steps step by step, then you will get the answer correct, and 5 out of 5 marks for this question. I hope you understood these tips and tricks, and if you want to continue with our regular classes batches, I have left the contact in the description box. You can straight away connect to our one of the executive. We will ensure that you will get the good grades. Fine, thank you, enjoy the physics.